Hey everyone, welcome back to another TxePrep video, and in this video we're going to look at USACO 2021 January Contest Bronze, problem number 3, just stalling. And basically what the problem says is that Farmer John has n cows of heights between A1 to AN, like A1 through AN, and he has a barn of n stalls with max height limits of B1 to Bn. So for example, if B of 5 is equal to 17, a cow of at most height 17 can resolve in stall 5. So, and how many distinct ways can Farmer John arrange his cows so that each cow is in a different stall and the height limit is satisfied for each stall? So the input is given to us where it's n, and then it contains basically the A array and then the B array, and all heights and limits are between 1 to 10 to the 9th. And the output is basically the number of ways that we need to do it. And it also gives us a warning that these large sizes of the output might require 64-bit integer, like long, because of how big the output would be. So let's actually try this test case out and see what happens. So I'm going to basically get in 1, 2, 3, 4, and 2, 4, 3, 4. So my A array, which is over here, I'm going to call this A. Oops. I'm going to call this A. I'm going to give it 1, 2, 3, and 4. And then my B array is 2, 4, 3, 4. 2, 4, 3, 4. Right? And we basically want to figure out how many cows can we place in each stall. And I think the best way to do that would be to sort it. So we can basically just transform this into 2, 3, 4, 4. So now we see over here, well, we can place 1 and 2 in stall number 2, right? We can place 2 cows in here. So I'm going to call this cows that we can place. Like, I'm just going to call this cows. Actually, I'm just going to call this C, right? So I'm going to call this array C over here. So we see that, okay, we can place 2 over here. And we can see that, okay, for the next one, we can place 3 of them because it's 1, 2, and 3. So we can place 3 cows over here. And what we can do next is we can place, for the next one, we can place 4 cows, so all of them. And same for the last one. But we want to find the ways, like, we don't just want to find the individual ones for each stall. We want to find, like, how many possible orderings are there. Right, so for example, for the first one, we can place 2 cows. But then on the next one, we can only place 2 cows. And the reason why is because we already placed one of the cows before. So we have to kind of subtract 1 from here. We have to subtract 1. And for this one over here, for this index 2, we see that, well, we've placed 2 cows before, and we can place a total of 4 cows, so now we can place a total of 4 minus 2 cows. So now what I'm going to do over here is we see, well, this is index 3, and we placed 3 cows before, so now we can only place 4 minus 3 cows. And then our final number of cows over here, so I'm going to call this F, is going to be 2. Well, 2 minus 0, well, that's 2, and then 2, and then 4 minus 2 is 2, and then 4 minus 3 is 1. And we can multiply all these together to basically find the total number of cows that can be placed. And now let's actually look at the code for this. So here's the code over here. So the first step I'm going to do is input n and create the arrays of A of n and B of n, basically just these stalls and the heights, basically the stalls and the heights. So I'm going to input them and I'm going to sort them, right? And what I'm going to do is I'm going to create a vector and I'm going to give it fit and I'm going to give it a size of n. And basically what that means is fit at I basically represents the number of cows that can fit in barn number I. So I'm going to loop through all the number of barns that we have, like all the height limits, and I'm going to loop through all of the cows that we have in terms of their heights. And what I realize is, well, I is going to be the barns, and J is going to be the cows, the heights of the actual cows. So if the cow height is less than the max height, then we can add that cow to the fit array, so to the fit at that specific barn, so we can increment it. And then our answer at the end would simply just be, basically we need to create a long answer, and I'm going to start it at 1, because there's obviously going to be 1 starting position no matter what. But otherwise, what we're going to do is we're going to multiply it by fit of I. So as we saw over here, that would be our C array. So fit of I minus I. And the reason we chose minus I is, for example, because we see over here that we've already placed cows before. So we need to subtract the number of cows we've placed before. And then at the end, we can just multiply all these together and get our final answer and print that out. So if we run this over here, let's take this as an input and paste it over here. And we see we get an answer of 8. So let's actually submit this and see what happens. So here I am about to submit the solution, so let's submit the solution and see what happens. So it's grading. And we should get the first test case because as we saw before, but in terms of the rest of the test cases, we will see that we do get them. Yeah, we do get all the test cases, so that's pretty good. So kind of in recap, what we did was we sorted the arrays. First of all, we input the arrays, we sort them, and we basically found out how many cows can fit in each barn. And after we found that out, in order to find the answer, what we did was we basically multiplied the number of cows that could fit in each barn, and subtracted that from the index to basically see that, okay, well, we've placed I number of cows before, so we can't place those cows again, so that's why we're going to subtract I. And that's how we got this formula over here to basically calculate the answer. So